So I've got a Lewis symbol, and that is for one atom. And a Lewis structure, this is one molecule. And so we'll need our definition for a molecule. This is atoms with covalent bonds. All right, so covalent bonds, I'm using the language here, sharing electrons. It includes nonpolar and polar covalent, okay? So we're going to cover both of these. Even the book likes to extend the Lewis symbols and use them too much. They're kind of like Legos. You can put things together and predict the structure of some molecules. But once you really start getting beyond just the very basics, you want to switch rules to the structures. So this is what we'll do. We'll do, if it's a Lewis symbol, it's a one atom, and then Lewis structure. As soon as you get two atoms, go ahead and immediately switch over to the structure. So both of these rely on rules, but we'll do them in a series of steps. Okay, so let's start with our symbol, our Lewis symbol. And this is a great way of indicating the atom and its valence electrons. So let's do nitrogen. So we start off, you draw the box for you draw your symbol. We're going to imagine that I have a pen that writes. Oh, that's the same color. That's good. Hang on. There's a box. Okay. We're imagining our box around the symbol. It's got four sides. Okay. Makes life nice and easy. Now here's our rules. One dot for each valence electron. Okay. No side has more than two electrons, or two dots. And then the last little rule here is no side gets two until all sides have one. Now this is a lot of stuff going on and going in here, okay? A little bit of the off-ball principle. We're doing no sides more than two. All right, so that has to do with our Pauli exclusion principle. No side gets two until all sides have one. This is actually related to Hund's rule. And so it all goes back to electron configurations and electron diagrams. But this set of rules, you'll notice, is missing a couple of things. It doesn't tell me which side to start on. It doesn't tell me which direction to go in. Doesn't matter. All right, so nitrogen, I'm going to look at that on our periodic table. So I'm going to come over, I'm going to find nitrogen. Here it is, nitrogen family. It's in 5A, or group 15. Okay, it is, you'll notice it's in period 2. It's a non-metal. All right, now 5A tells me it has 5 valence electrons, or I can do 15, we're subtracting 10. We can just take this 5. Okay, so 5 valence electrons. That means 5 dots. Start up here. I'll go clockwise. Why not? Notice, instead of putting one there, I put one over here. 2, 3, 4. Okay, now this is a great use for the representative elements. We can do the octet rule. Remember the octet rule, everything's trying to get to 8. And 2 for helium. All right, everything's trying to get to 8 unless it's trying to get to helium. It's trying to get a full outside layer, or there's a secret way of getting to this. You can empty the outside layer. So this is my symbol. Now, what does it tell me? Well, it's got all kinds of information in here. For one thing, it's got an empty spot here, an empty spot here, empty spot there. And that helps me to predict where it's going to make a bond. So we could say if this is going to become an ion, so if this was an ion, it's going to make a -3 charge because it will gain 3 electrons. If it's covalent bonds, then this helps me to identify. So let's look at how we would do a covalent bond. So here's hydrogen. Now, hydrogen's special case. It's only got one side on this box because it's only in that one S. I'm going to put that down here, right here, like that. So it's even easier to see. Now, this hydrogen wants to get to 2 to be like helium. If these share, then this would be a covalent bond. And these electrons would both be around hydrogen and around nitrogen. So now I've got 1, 2, 3, 4, 5, 6 around the nitrogen, and I've got 2 around the hydrogen. It means hydrogen's happy. So if I add another hydrogen here and another hydrogen there, then I would get each of these happy, and I would have 8 around my nitrogen. And so we can predict that nitrogen makes 3 covalent bonds. Okay, so it's got these 3 empty spots. It's going to try and make 3 covalent bonds. Beautiful. All right. You'll notice, oh, wish I had different. Let's use this black one here. This pen, this pair, I didn't talk about. It wasn't involved in bonding. That pair is called a lone pair. And this lone pair is found only on one atom. That's why it's alone, all right? So it's not involved in bonding. Not involved in these covalent bonds. So this nitrogen has one lone pair, would make 3 bonds. So we can summarize that kind of information. And now I can use this for all kinds of stuff. Let's look at oxygen. So oxygen, when I look it up, it's in group 16. So it has 6 valence electrons. All right, so I'm on oxygen. I'm imagining my box. We don't usually show it. Okay. 6 dots. Doesn't matter where I start. 1, 2, 3, 4. It didn't matter which way I went. No side gets 2 until all sides have 1. 3. Let's see. 1, 4, 5. Let's put 6 over here. So I'll make them a little bigger. They're easier to see. All right. We've got an empty one here, an empty one there. It's going to make a -2 charge if it was ionic, or it's going to make 2 bonds if it's covalent, and it has 2 lone pairs. 2 lone pairs. So we use this kind of stuff all the time. Let's pick on sodium. Sodium has, it's in group 1. It has 1 dot. Now, it could gain 7 to fill up the rest of its outside, or it could lose 1. And so we can predict it's going to lose 1 electron. That'll make it a +1 charge. And it'll do this rather than try and making a bunch of bonds, single bonds, because these just too much work. So it's going to be ionic. And remember group 1, we had our chemistry man cards, as I like to call them. Group 1, if it's with something, is always going to be a +1. And we can see that from the Lewis symbol. So summarizing some things we find about the Lewis symbol, I can say that nitrogen and things in its family, 3 bonds, and that's because it has 1 lone pair. Oxygen likes to make 2 bonds. Now this is with no charge, so we're not going to change the number of electrons. All we would do there is add dots, take away dots. All right, so 2 bonds, 2 lone pairs. Let's do fluorine. So I'm going to sketch it over here. It's a halogen. It's in group 17. So it has 1, 2, 3, 4, 5, 6, 7. It's missing 1 up there. So fluorine, it's got 1 bond, 1 lone pair. We saw a while ago, hydrogen's got 1 bond. Whoop, that was wrong. Fluorine has 3 lone pairs. There we go. Hydrogen has 1 bond, no lone pairs. 0 lone pairs. It can only hold 2 electrons. 1 bond's got 2 electrons. There we go. All right, so carbon, 1, 2, 3, 4, because it's in group 14, we can see carbon makes 4 bonds. Oh man, no lone pairs on it. So when I do these, this carries all the way through. If I teach organic chemistry or Fun Chem 2, I make my organic students just flat out memorize this. But it all comes from these Lewis symbols. All right, I can say nitrogen makes 3 bonds, oxygen makes 2 bonds, the halogens make 1 bond, hydrogen makes 1 bond, carbon makes 4 bonds. Okay, so and the way I always did that is I'd quiz them on it. So I'd say carbon, how many bonds does carbon make? 4. How many bonds does hydrogen make? 1. How many bonds does a halogen make? 1. How many bonds does nitrogen make? 3. How many bonds does oxygen make? 2. Oh man, not too bad. This stuff is pretty straightforward. And we can see that stuff like aluminum, it's got 1, 2, 3. And we could predict it's going to gain 5. And so aluminum is one of those we can also come up with like a man card. This is always a +3 when it's with something. Aluminum likes to be ionic. All right, so it likes to be a +3. All right, so that's our easy stuff for our Lewis symbols. They're not very difficult. Where we run into difficulty is when we start looking at some of the questions in the book where they try to make us put things together. So instead, let's go to Lewis structures. And I'm going to work an example here. Oh, let's do CO2. And I've got my rules over to the side here. So let me show you these rules a little bit. And these are my steps. Now what I do, when I'm doing these, all right, I'm going to give me